somehow at some point it like figured it out. And, like, adjusted the time zone and got some Wi-Fi network somewhere and it figured it out.
Yeah.
It's pretty funny.
It does it like from like I'm not sure though. Maybe
I mean the GPS would make the most sense, right? Yeah. Because it's all time-based. But I don't know if they're doing it, so it makes sense.
it would be kind of like it could be potentially inaccurate depending on like if you have like no GPS. Or if like you get like a bad GPS thing or something. Anyway.
Yes, indeed.
Give everybody the benefit of that until it's right at 30.
This isn't on. No. Oh, that's. Oh yeah, that's all. That's not plugged into your thing.
It isn't.
Oh, there's the plug. Who?
Wait for it. Going down there.
I don't know if that's an 85-watt one or not.
Yeah. Maybe this one doesn't work or something. It blinked or something.
Yeah.
This is yours?
The
Adapter.
Yeah.
Yeah. Yeah, it's probably not going to be. Well, it's probably the colleges or something. So we'll see. I'm not sure. Yeah, that's better because you have a different machine. All right, let's get started.
Let's do it. There, sure.
That's mine. Okay, we're going to get started. Our next talk is by Brian Dorsey, and he's going to be talking about visualizing metrics with ZeroMQ, Redis, and Graphite. And I hope it has something to do with Python.
There's some Python in there somewhere.
Is there? Okay.
Yep.
All right,
Promise.
take it away.
Okay. Hello. Hello. Thank you for coming here. End of the day, and we'll have some awesome metrics madness. Okay. So context. I had a system where I had about 50 servers spread across 50 different machines, and they did really interesting work. And I'll bet you guys have written lots of Python servers that do some kind of interesting work. And for this talk, it doesn't matter what the work is, as long as it can be measured in numbers. So numbers over time, and we can go. So I thought it did interesting work, but I wasn't sure. And the whole rest of this talk, we'll see how to find that out. I wanted to just pay somebody to draw graphs for me. I'll send them numbers, and they'll draw pretty graphs, maybe alert. It turns out to be very expensive if you want to send a lot. For example, I wanted to capture about 20 metrics in a prototype, like 10 to 20 metrics every 5 seconds. And over the course of a month, that's like 500 million data points. And so if you think 500 million points at a hosted service, it can get very expensive. So I want inexpensive. I don't want to write anything because I'm lazy. But I'm making a prototype. I'm trying to learn about my software. So I want it to be easy to extend and flexible so I can change my mind later. And extend is just more metrics, and flexible is doing something different with the metrics. And because this is a prototype, I want to play with some new things. So hey, thank you, Etsy. Have you guys seen Etsy.com? They have an awesome blog, Code is Craft blog, and they basically said, here's how to do this. And specifically, they point at something called Graphite, which I'll talk about. And they wrote this thing called StatsD that takes all the numbers in very, very fast and pools them up and aggregates them and sends them out, which is awesome. But I was trying to learn about my service. I didn't want to deploy yet another service on all 50 machines. So I did something different. I'll just let you read that. So with my apologies to Philip Greenspung and his everything turns into Lisp eventually. So I kind of wrote half of Etsy's metric system. So plan for this talk, I'm going to talk about each of the three pieces, Graphite, Redis, ZeroMQ, and then the glue that I use to put them together. That's where the Python comes in, Ian. And some alternatives and other options and ways to improve it from there. So, Graphite. It's scalable real-time graphing. They have all the buzzwords. It's enterprise. This is their website. It's graphitewiki.com, and it's open source. And what it does is it takes numbers in, stores them, and makes graphs. So Graphite is all time series data. So numbers over time stored on disk. And it looks something like this. Maybe you have some data, one row at a time, and these guys are the actual measurements and time. And then it goes into Graphite, and you get graphs out. So that kind of thing. It has a bunch of parts, mostly the storage and caching, the actual storage, and the web app. And I'll just leave these here for the slides. At the end of the talk, I'll tell you where the slides are, and if you want to look in more detail, you can do that. But one key thing about Graphite is it stores, before the key thing, every data entry to Graphite is 3 parts. There's a name, the actual value, and timestamp. So if you have historical data, you can include the timestamp and go back and refill with old data, which is kind of handy. It has a small admin UI, and the dots in the name turn into things here. So like host, load average. So every dot is one level in the hierarchy there. And the key thing about Graphite is it stores everything in a round-robin database. So who's heard of a round-robin database before? Maybe just a couple people. So it's kind of made famous by the software called RRD tool. It's used very commonly in the networking world and lots of monitoring apps. And what an RRD database is, it's basically a ring, and each spot is where the values go. And as time goes on, you eventually come back to the beginning and just keep overwriting in a big loop forever. So all the way through. And then it's a stack of these. So you define how much detail for the day and run a function like maybe average to get you to week and to get you to month and everything. So the magic here is that no matter how much time you're doing, it uses the same amount of space on disk. So you can store a long time worth of metrics in progressively less detail as they get older, but you still have trend data in the same amount of space. So you won't have a huge explosion of log data or things like that. It's very predictable. So there's the admin UI again. And then this UI kind of lets you play around with making graphs. And the way you use graphs in your own kind of visualization system is basically kind of right-click and grab the URL, and you'll get this kind of big, ugly URL that you get to use and embed in your scripts, your web page somewhere to show that information. So that ends up becoming the HTTP API for making graphs. And it just goes in an image tag, and Graphite makes the image based on now every time you request it. So as it's refreshed, it's up to date every single time. And the graphs are very customizable. So you can change all the colors, the lines. They include functions for smoothing the data, for comparing to historical data, like 1 week old data, things like that. And you can also group metrics from across servers or things like that and show them on the same graph. Okay, boom, Graphite. Now onto Redis. This talk is going to be a little crazy. So Redis is open source advanced data structure server is their tagline. And this is their website. And if you haven't played with Redis, I highly recommend looking into it. It is very, very, very worth your time. Seriously. Just play with it. A kind of short version, Redis can be a whole talk in and of itself easily, but it's a key value store that operates in memory, and the values can be actual real data types. So you can have just a string, but you can also have a list, or you could have a hash, or you can have a set of strings, and you can do operations on those things. So it gives you this very powerful compromise, I think, between just a straight key value store and other kinds of databases. And it's completely in memory, so it behaves more kind of like memcache speeds, but you have the limitation on RAM in your total data size. Redis is a little hard to say what it is because it can act as a cache. You can give the key an expiration and it will go away. You can think of it as shared data structures for different processes because they can all access the same keys and do work on them. It has blocking operations, which we'll use in this talk, which allow you to make queue-like systems. You can also do pub-sub messaging, replication, and some other scripting, and it goes on a little bit, but it's amazing. It also has very good documentation, down to big O notation for every one of its commands, which is really amazing. But we're only going to use 2 of those commands today. Push and pop. And the L is left and the R is right. So these operate on lists in Redis. And if we have some key that we're operating on and we add an A to it, we just get an A, B, C. We can see how long it is. We can get the whole thing. Or we can pop things off and we get them back out in the same order they went in. So it's just kind of a doubly linked list that's cheap to operate on either end. And it's stored in memory in some outside process. Is that okay? Because we're going to use this a lot. Now, this, if you add a B in front of it, it makes the pop block. So if there's nothing in the list, it will wait forever, or until the socket has problems, but it'll wait until there is some value. So you can have software just sitting and waiting to do work, And the moment anyone pushes something in the list, it'll come out and start working on it. Okay, so remember that. Next one. ZeroMQ. So ZeroMQ is also a little hard to talk about. How many people have used ZeroMQ in here? Okay, so it's not a message queue. So for that MQ, it's more like a toolbox with all the pieces in it you would need to build messaging things. And you could build a queue out of it. I used it because one of the guarantees that ZeroMQ makes is that every message you send in will only come out the other side if the whole message makes it. So I've got this guarantee that I never have to deal with split UDP packets or things like that. You get the whole message or you get no message. ZeroMQ does many, 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 many things, and I will let you read about it, or that could also be a whole different talk. In this talk, we're just going to use pub/sub, which is publish subscribe, but I'm going to use it backwards with one subscriber, and all of the services are publishing data to it. So this is kind of a collector here. And this is sitting at a known port, and all of these guys connect, and they publish up to it. If the network connection is bad here, it can come and go. We'll lose some of the messages, but we will never lose a partial message because of ZeroMQ. So some messages won't make it, but this is metrics, so that's okay. That sort of thing. So I could have just used UDP sockets. Probably don't need ZeroMQ, but it was very convenient in prototyping to never have to worry about like packet splits. This was going across satellite networks and lots of VPNs in between, and it's never clear to me when you're going to get a UDP packet split or not. So that's where I was. Okay. Now for some Python. So 3 pieces, right? Graphite, Redis, ZeroMQ. And then we're going to build something here. And this is what we're going to build. So I added one new thread to my service that just woke up every 5 seconds and sent status. So sleep, wake up, send status. And since that was built into the service, next deployment, it's out everywhere. It's all same Python, same stuff. We have our listening subscriber, which pushes into a Redis list. And then this worker is blocking on this same list, does some parsing of the status, pushes it into an outgoing queue, and then this guy pushes it into Graphite. So I'll show you some code now. We'll see this again. So the first is the publisher that lives inside your application. Now we have code. Okay. So this is just kind of anything, that makes some statistics for your application. So I just made up an interesting metric that is the mod of time. So it just counts upward to 100 and then back down to 0 and upward to 100, back down to 0. And value name time. This is the ZeroMQ config for making a publisher that connects outward. And then here's the whole loop. We get stats, we dump it to a string, compress it, send it over the socket, and sleep. So just very simple loop. Doot, 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 doot. On the other end, we listen, and kind of the opposite setup for the ZeroMQ. This kind of no parameters to Redis will connect to localhost. And then this is super tiny. Receive, push. So this one, all it does is just sit in a loop, just waiting for new things to come in. No processing, so that it gets things off the network as quickly as possible. Okay, then we've got our worker to do something useful with the statistics. And it's also blocking. So it's blocking on this Redis list. So this while true will start and then block until some stats come in. And then it decompresses, parses the JSON, and uses the JSON to assemble this string. And this kind of looks like our dotted name, number, time that we're going to send on to Graphite. And then it pushes it into Redis again in the outgoing side. And now that we've got that, we need to actually send it to Graphite, which is the same kind of deal. So we connect to Redis, and then we need a little socket to talk to Graphite. The Graphite has 3 different APIs, but one of them is a raw socket with a new line terminated bit of data. And so we block on this, add the new line, print it for fun, and send it down the socket. So all of this is missing actual error handling, but you'll run into those errors at some point, so you can add them in from the demo. And then we need a web page to see these things, right? So this is the whole web page. We just have an image that points at wherever our Graphite host is and does that. And when I did this, I used Supervisor D running on Linux to run these scripts and keep them running. So if they crash, they get restarted. Supervisor is really handy and simple to configure. But if you have a favorite process monitor, you can do that. But it's handy to have something in charge of running the scripts so that if a reboot happens, they get restarted. If they crash, they get restarted, that sort of thing. And that brings us back to here. I should have that colored again. Just as an aside, both Redis and Graphite work way better on Linux, Mac, not so well on Windows, if at all. So, okay, so that's kind of a lot of parts. When I did this, I took my 50 servers and I ended up sending status every 5 seconds. So that's about 10 a second. About 20 metrics, 20 numbers per stats JSON package, which is about 200 data points a second, or about 500 million a month. And then I got busy. You know how this happens at work, right? You get something that kind of barely works, and then everything changes, and you have to go do something else, but it works. Let's use it. So 5 months later, it still worked. and Redis had processed 4 billion operations. And I really like it when things just work. It makes me very happy. So that's part of the reason I wanted to come and share this with you guys. So this is kind of the kind of straight path through. But the nice thing about having these 2 queues in Redis set up there is we can then hook anything in from here, right? So the slowest code in this whole bit was actually parsing the string back into JSON on the central worker. So if you had some, JSON's maybe not the best reason to do this, but if you had some heavy processing you wanted to do on each stats update, you can just make more workers, run them on different machines, easily, kind of address that bottleneck. Or you could just get the center out of that job entirely. So maybe you could send smaller messages that were already the strings made for Graphite up front if you weren't prototyping. Maybe you could batch them and summarize them. And wait, isn't that what statsd is? So if you want to send like many metrics from a lot of workers, like say you want to do stats on a high traffic web servers, then it's worth looking into statsd, or there's a bunch of statsd clones as well. So that's something to run next to your services. So again, thank you, Etsy. Or what if you don't want to modify every one of the applications, or some application is owned by a different group, but they have an API? Then you can just poll for it, or parse logs that you have. Anything you need to do to get numbers and then add them into this system. So you can just add a little poller, and as long as it goes into the same outgoing spot, all the metrics will end up in the same system. Or if you want new metrics, you just change what you're gathering and send those along down the pipe. Or if you want to do new work on the status, just update this one bit. Instead of just kind of passing it through, maybe do some calculations or something. What if you aren't sure if Graphite is the right thing? You want to kind of use some hosted like visualization tool, or somebody says Cassandra is the way to go for storing everything long term, and you want to keep detailed logs forever. You just kind of have this guy split and send to the other service at the same time as it does the Graphite work. Or, and this is what ended up being very useful in my application, you can go ahead and pre-calculate common views for your application and store them in Redis as a cache, and your application can read directly from there rather than talking to wider parts of the system. So you can put extra keys in Redis at the same time you're passing the work on. So if you kind of aggregate the stats or manipulate them in some way to use for your application, you can do that here. And that is early, so we have plenty of time for questions. Did that even make sense? Got some smiles.
Not so much a question as a note to it. There is a Redis port for Windows.
Okay.
It's actually by Microsoft, and I can only assume it's fairly stable if they did it. So if your development environment is Windows, for Redis alone, you don't have to have a VM.
Okay, that's really worth looking into then, because Redis is awesome, and yeah.
The another note on the Redis is it's actually persistent.
Okay.
So you know, like there's a threshold, but basically it's fast enough that you can easily forget about this part of the system.
Yeah. So, yeah, I skimmed over lots of parts of these tools. They're worth looking into, for sure.
Do you have a question?
So you were on your servers that do interesting things.
Yes.
You were like gathering, you're sending stats every 5 seconds instead of like when an event happens.
Yes.
So, whereas I guess this kind of related with the statsd thing because they just send like a UDP packet.
Yep.
So would you like use ZeroMQ if you were sending when an event happens instead of like every 5 seconds? Does that make sense?
I think for me, the main value I got from choosing ZeroMQ was I fear UDP packet splits, and I was sending large data with the stats.
Right.
Basically, when I did the prototype, I took an internal application data structure and just JSON zipped it up and sent it because I didn't know what I wanted.
Okay.
So a better way to do that would be kind of know what you want and only send that. And if you only send the important parts, you can probably send them in small pieces and be perfectly fine with UDP.
Okay.
Yeah.
Yeah, it's just a quick question. Why did you choose JSON over Pico?
Over what?
Pico.
Pico?
Yeah.
I didn't know about Pico. I'm ignorant.
Yeah, Pico.
Pickle.
Because
I'm
the
sorry.
internal-
No,
internal-
okay, so I fear pickle.
Oh, really?
Yeah, I especially fear pickle when sending it across networks between potentially different versions of Python. It didn't actually really occur to me, but it's pretty easy to, I guess you get burned by something once and you never do it again. So that's probably why.
Anybody else? Questions?
Okay. And I have kind of a little demo if people want to look at it later, or and the slides are all up here, and all of the scripts are there. And if you have an Ubuntu VM, you should be able to run through the install blog and run all of those programs and see this actually flow through. And you'll see something that looks like this. That's the great, interesting work, like graph. But so be it. So thank you all very much.
Again, we're having lightning talks later, so and we're looking for people to give lightning talks in English, so if anybody wants